we'll focus on the security as we talked about. We believe that traditional NAC is broken. Customers are telling us, and I talked to hundreds of CIOs and CISOs, and clearly telling us that the NAC is no longer meaningful for them. It does not meet evolving needs. Analysts are telling us that. And we're seeing that, why customers are buying Nile is because of the zero trust that we have built in. Why is that? Let's talk about it. Traditional NAC is broken. It's built on, frankly, on a broken infrastructure. The network is a permissive network. You start with the VLANs. It's a permissive network. Then you're trying to bolt on. Today, 60% of the cybersecurity attacks happen because of the vulnerabilities in the network. As we said, you come in, you discover the network, you discover all the resources connected to the network, and you start propagate the malware. That's a foundational problem. And especially OT devices cannot protect themselves. And now, JJ, to your point, there are overlay solutions that are coming up and trying to do /32. So we're doing band-aid solutions after band-aid solutions. And then other one is, as you guys know, doing the wired .1x is almost impossible. Doing the host isolation on the network is impossible. There are customers who have spent 5,600 hours, 2 man years, to make sure the host isolation happens. And as soon as something changed, it all failed. So this is why the customers have given up on trying to make the NAC work on the wired networks. There are some, and we continue to use the VLANs. As you guys know, VLAN is basically you can communicate with each other. Initially, we started VLANs for limiting the broadcast. Then we started using voice VLAN and data VLAN for the quality of service. Now we're using VLAN for the segmentation purposes. So again, trying to leverage what we created 30 years ago and trying to use it for different purposes. And it is permissive. It does not align with the zero trust principles, which is the default deny, continuous authentication authorization. Every user and device has to be authenticated, authorized, least privilege access. None of these principles are, VLAN or the NAC can provide you those capabilities. And let's be honest, when you look at the reports that are coming from the analysts, they're saying that, the NAC market is going to go down significantly because it no longer meets. And it's going to be replaced with campus zero trust. And what we call, so when we talk to customers, they have told us explicitly, my remote users are less secure than office users. That's kind of counterintuitive. You would think your office network is a lot more secure. The reason is when you're a remote user, you're using one of the SSC provider, they have the client connector, talking to the SSC and then going to the application. Every user is isolated and protected from rest of the environment. Once you come into the network, you have the IT devices, OT devices, your device is exposed to the rest of the devices on the network. And you're dealing with .1x, NAC solutions, VLANs, all of these things. This is what customers are telling us, that remote users are more secured. And what do they want? Again, we have a customer advisory board, and we talk to a lot of CIOs and CISOs who are running enterprises. They want to go to universal zero trust. Whether it's a remote user, office user, employee or guest, or IT device or OT device, you need security across all of these locations, not just one solution for something and another solution for something else. So customers for the remote users, they're going with the SSC, they'll continue, there are lots of solutions, great solutions. But when it comes to the on-site, when the employees come to the on-site, that is where the campus zero trust comes in, where every user is authenticated, authorized, every user is isolated from another user or every device, and we give you micro-segmentation capabilities, and you can define granular controls. And with the, so no longer NAC, you're no longer dealing with any of those challenges. It's a true campus zero trust that comes out of the box. And more importantly, it can connect directly to the Zscaler or Prisma Access or Netscope or any of the SSC solutions out there. We integrate with them, and the traffic is automatically going for all the north-south. Everything east-west that's within the building is protected using campus zero trust. And what does it mean? So I'll not spend a lot of time. We'll go into more details. Hey, here are the NAC capabilities. We need more capabilities in NAC. It needs to be built in, not a bolt-on. So these are all the capabilities that you need in order to meet the campus zero trust definition. All right. With that, I'll hand it over to my colleague Shiv again to go through all these the details between the NAC as well as the campus zero trust and continue on campus zero trust.
Thank you, Suresh. So one of the key things that we are trying to do is, and you'll see the next few slides in this theme, is we're talking about infrastructure, access, and policy. So infrastructure is the underlying infrastructure, what you need to do secure. It follows the zero trust principles. Access is how do you gain access to the network, basically authentication. And then policy is once you're on the network, you have an IP address, what can you do, right? So in those three buckets, if you start with traditional networks, you are talking about TACACs, right? That's what's being used. You try to control who can access the network. In the zero trust world, especially in the service model, we're saying, why do you need to access that hardware, right? The hardware should be built with all your logs, everything streamed, in real time. You need that last breath. We can use a mobile app, but eliminate that whole access need. And the only reason is, hey, if we can access it as Nile, someone can break into it, right? And this is our responsibility. So we have to lock it down as tight as possible, right? Second is encryption is not there by default, right? You can buy a switch that supports MACsec. Setting it up is a nightmare. I don't know a single customer who's really set up MACsec. With Nile, that comes by default. So an AP to switch is MACsec encrypted. From switch to switch, it's MACsec encrypted. So if you try and snoop those traffic, you're just going to get encrypted traffic. And this is completely done in an automagic format where these devices come up. It's designed to form that MACsec connection with its peer. And then also mutual authentication. That's not something that's done today where you mutually authenticate with your controller or with a switch. With Nile, it's end-to-end, right? The AP authenticates to the switch and vice versa, switch to switch. All that stuff is again built in using the certs that are burned on these devices, right? So we're trying to make sure that the underlying hardware is as airtight as possible, right? And we'll have Avinash talk us through a bit more details. Next, the default switch does not come with .1x enabled or MAC auth enabled. You have to identify those ports. You have to basically use an external ICE or a ClearPass or any of those NAC solutions to really tie all this stuff together. With Nile, that comes baked in, right? The campus zero trust should have .1x, SSO, MAC auth. You name all the auth types that exist today. It should be in an automated fashion and as simple as possible, right? It should not be a default allow. There should be no bridging so that you avoid any of that layer 2 malware propagation that can happen by default. The VLANs, it's a big burden, right? Let's face it. Sure, if you have a retail site, everything is cookie cutter. You can use templates and just paste it across. But that's not true in enterprise, right? Every closet is a snowflake. Every closet has different configs, different types of devices connecting in. Manufacturing, people randomly plug stuff, loops are formed, and these are all the doings of VLANs, right? And let's not use VLANs for what it wasn't designed for. And that's why it's a full-blown layer 3 network. You don't configure it. It's all identity-based. You create rules, you create policies, and if nothing matches, you can manually go and override that stuff. Identity-based auth is very, very critical. We think that's a cornerstone for zero trust. And we'll see a bit more in detail. It's not just identity; it's even a device posture that go hand in hand to make sure that the policy is appropriate. And we'll give you a good example around that. Continuous authentication in Nile, SCIM is all built in, and we'll talk about that. You basically disable the user right off the network, right off the bat, right? You don't have to worry about whether certs are expired, whether they have the PSK key, none of that stuff, right? So it should be continuous. MAC spoofing, why should we set up MAC spoofing today? That should just be there by default, right? That is a vulnerability that exists. So let's not worry about configuring it. It should just work, by default. Default devices, you can, from a policy perspective, everything is allowed to talk to everything by default, right? You have to put in the rules, the policies. With Nile, it's the opposite. Zero trust should always be either deny or least access privilege, right? That's what you want to talk through. And then finally, ZTN integration should be very simple. You just give us your API key, your provider, and that's it, right? What POP to go to, how do we connect, all that stuff should be fully automated. And that's something that we think completes entire campus zero trust, which is making sure everything in the access layer is airtight, and then anything beyond the WAN is within SSC integration. So with that, we'll walk through these three buckets of infrastructure, access, and policy. And I'm going to hand it over to Avinash to take us through that.
So thank you, Shiv. And I'll cover some of the key aspects of infrastructure security. The first one being the trusted platform module. So each Nile element comes equipped with keys, cryptographic keys, which are actually stored within the TPM module. So these hardware-backed keys will actually provide for a strong authentication and prevent against key extraction attacks. The second one is against secure boot. So secure boot basically ensures that there's a trusted, immutable boot sequence for any of our devices, and it uses cryptographic authentication again to ensure that only Nile authorized software can run on these devices. What this ensures is that anytime a Nile element comes up, it starts with the basic security level, and it protects against, say, tampering or even reflashing attacks. Thirdly, it always runs the latest software or patches, and the way we actually push it from the cloud, like say a hotfix, is always over a secure TLS tunnel. So you can't have any other channel through which you can actually push these hotfixes or patches. And lastly, all access to Nile elements is actually secured. What does this mean? Typically, network infiltration starts with network discovery. You have protocols which you'd use for network discovery, like whether it be CDP, whether it be ISMP on which you have ping or trace route, or you have LLDP, these are blocked by default on Nile. See, in spite of this, there is some determined intruder who actually wants to get into the box and understands the NSB IP. The next thing they would do is try to establish a connection with this particular element using protocols like, say, Telnet or SSH. Telnet is blocked by default, and SSH is actually disabled. I would also go ahead forward and say that even for a Bluetooth interface that we briefly discussed, the Bluetooth interface itself employs an authenticated access with associated data algorithm, which prevents any kind of unauthorized access. So as a result of this, in any of the follow-up infiltration attacks, which would be like you would actually try to do privilege escalation, or you could actually do reconnaissance or lateral movement, those are all stopped. Okay. Further carrying on, like Shiv mentioned, each of the devices or each of the Nile elements between each other, they set up TLS connections. And this uses the previously mentioned identity certificate, which is burnt into the TPM. So you can't have unauthenticated elements try to connect to the NSP. The next one is all the communication between the Nile elements and the cloud happen over a TLS connection again, where both the client side and the server side certificates are validated. These are X509 certificates. They're validated, and a trust chain is established. And only thereafter a message is sent over the TLS tunnel. And the last thing I would want to mention is MACsec is enabled for traffic encryption. This basically ensures that the data packets that are flowing are encrypted, and there's integrity which is enabled on it. And this secures all our Ethernet links, whether it be from the AP to switch or from the switch to switch, again preventing against eavesdropping or tampering. With that, I'll hand it over to Shiv again.
Thank you, Avinash. So let's talk about access, right? So right now we have tried our best to make sure that that network is as airtight as possible. So now how do devices access the network? So we spoke to you about the switches being completely blocked by default. They're colorless ports. It's an explicit deny. You cannot do anything without being authenticated. So from an authentication standpoint, we basically have three options, right? You can either do .1x. If you do .1x, we go to the Radius server. The Radius server tells us, put this person on segment A, segment B, segment C. And segments are nothing but layer 3 constructs. If you go to the Nile portal, you can create a segment called employee and just say employee means 192.168.1.0 in site A. It means 172.16.20.0/24 in site B. So it's nothing but a subnet mapping, right? So Radius server gives us a Nile VSA or a tunnel private ID, and we can then put that device on the segment. So that's why there is no config on that port, because the Radius server will tell us. If Radius server doesn't tell us, we can do a MAC auth, and MAC auth we can do fingerprinting. So you can actually say, HP printer 5011 is supposed to be in the printer segment, right? So when that device comes online, we fingerprint it and we basically put it on that printer segment. Third option is if you don't have any of those rules, you can create this catch-all pre-auth rule, if you will, and we'll double-click on that in a minute. And you can actually do guest or .1 or SSO on a wired device, right? So literally you get your corporate IDP page as a redirect page. You put in your credentials. You can basically go and do multi-factor authentication, and then you get access to the network. So that's how we basically make sure that these devices are not on the network by default. They have to identify themselves, whether they're IoT, OT, or users. It doesn't really matter. And then finally, once all that goes through, that's when you can actually get a DHCP packet going through. So you're actually just going to send a DHCP frame. And while you send that, we're going to be doing all these things to verify who you are. And based on that, give you an IP so you can go and either do .1x or sorry, not .1x, but SSO.
You support multiple levels for guest authentication or the guest ports?
Yes. So what we support is you can do admin approved, you can do email approval, and that's, I think, the next slide right here. Accept terms and conditions, move on. We've got SMS coming as well. Yes, so multiple options. So talking about that, there are multiple ways to authenticate. Radius, you can have AD. AD gives us groups. Based on groups, we can basically put you on different devices. We can also integrate with ClearPass ICE, get the groups, and send that group information to Palo Alto using XML APIs. So you can do identity-based if that's what you need. We have single sign-on built in. All you do is set up an IDP. It takes 5 to 7 minutes to tie it with Nile. Once you set that IDP connection, you can use it to log into the portal as an admin, monitor, or help desk user, or you can use it as an end user on an open SSID, on a PSK SSID, on a captive portal SSID. So you can actually just have that option that if someone connects, force them to go through SSO. Skimmed integration is also tied. As I said, you can literally go into the IDP, disable the user. Right away, we get notified, we kick the user off. So you don't have to worry about revoking certificates, PSK keys, none of that stuff, right? Even though they might be on the network because they have the PSK key, it does not mean they can get onto the network. Finally, fingerprinting is built in. We use multiple data points, whether it's user agent data, whether it's multicast frames, DHCP frames, DNS frames. anything and everything that we can get that gives us a better score, and that's how we fingerprint devices. And us being inline versus ClearPass, where you just send a DHCP packet, our fingerprinting obviously is much more robust than what you would get from an out-of-band NAC solution. So let's quickly touch base on wired SSO. Wired SSO, all you do is you create these rules. You can say, .1x, you could have fingerprinting rules, and when that device plugs in, it does not meet any of those rules. It falls into this pre-auth segment, if you will, gets an IP address. Two things can happen. You can either do guest or you can do guest and wired SSO. That we can onboard people automatically. So universities love it because they have students, teachers, staff, and they have guest people who come and who present. So getting on the network becomes very easy. No admin intervention is really needed at that point. So if I just walk you through that flow, essentially when you try and do a DHCP, because you're just going to do, you're not doing .1x, we check all the rules that you have. It could be a MAC-based, OUI-based, it could be a fingerprint, does not really matter. We then put you in a pre-auth segment. Based on that, we go and check whether you are an approved user or not. If you're not, we get a redirect URL from our cloud. We send you to your IDP page. You log in, do MFA. Your IDP tells us it's all good to go. We then let you on the network, and we move your segment in the back. We move you to the employee segment, and tied with SCIM groups and stuff, we can even move you to employee versus employee versus HR versus sales, whatever you want, or teacher versus student, and then finally go through DHCP. So we make sure that this entire flow is something that enables our IT admin not to be sitting and approving devices one by one, because when it's an explicit deny, that's one big question that comes up. How do I authorize devices? Do I have to do one by one, which is obviously not scalable in a large network, and that's where all these rules come into play. Any questions? All right. So this is what I was talking about, where you can basically get a guest page. This is just accept terms and conditions. It could have been email approval. It could have been SMS. But the key thing here is employee login. And there are multiple use cases for that, right? One could be, I want to have my employees' personal devices on the guest network, but I don't want to kick them off every day or every week. I want a longer duration. That's where SSO comes into play. Or it could truly be, I want to give them employee access, and if they go through SSO, I will put them on the employee segment and then let them through. You can get best of both worlds. All right, let's talk about policy, the next one. And this is something that we are trying to redefine. Today, if you look at policy, it's all based on subnets for most part, right? Everyone does something based on an IP or location that you're plugged into. So with Nile, what we've done is we've actually re-architected this whole policy engine. First thing we do is we have defined a construct called groups. Groups are three types. You can have a user group, a device group, or an app group. And user group is anyone who can authenticate using Radius or SSO, if you will, or SCIM, right? With SCIM, we can get those group names. So you can create a group called employee, and then you can create rules that anyone who matches sales, marketing, HR, put them in the employee group. You can create an HR group or a sales group if that's what you want. But the idea is all users fall into a certain type of user group, if you will. Device, they're all based on fingerprinting. Now, mind you, you can also do everything based on subnets, the way you want to do it today. If that's something you want to do from a migration standpoint, we support that. But you can create device groups. Device groups would be based on fingerprinting. All printers, all my Zoom rooms should fall in the IoT group, if you will. Once you create the groups, the next one is the app one. The app group is anything external to the NSP, if you will. So all your data center subnets, all your applications, they can be an app group that you create. Now, with these groups comes something called an attribute set. Sorry, go ahead.
Just while you're talking about this, just referring back, you had a slide up that showed what Nile does, what the customer's responsibilities are. Customer probably has a lot of this already done. Is that one of the Nile things that you'll help them transition from their version to this version?
Absolutely. We will support them and try and move them over from what they have to what.
Is that automated at all? Or is this
It's not automated today because, as you can imagine, we were looking at a Juniper, output from a firewall perspective, right? Completely different, IP access list, if you will. So we will look at that data. We'll figure out what user groups you want, and we can assist you with migrating that over.
Is this much of a pain point?
Sorry?
Is it much of a pain point with your current customers?
This one?
The transition.
Oh.
So migration, frankly, for a lot of customers, as we were talking about, is not leveraging any of the East-West policies because it's extremely complex. Most of the policies are north-south, so that you can continue to keep in your SSC world or in our internet gateway or the edge service, but others for the east-west. We're able to migrate them through professional services. But many a time you don't run into those challenges because customers are using simple VLANs, employee VLAN, guest VLAN, and IoT VLAN.
But I mean, for groups, especially for users and devices, are you not just connecting into whatever IDP they have?
Absolutely.
And that's just a dynamic relationship integration that's persistent, then they don't need to do anything.
They don't need, all they have to say, I want to create an employee group, and as long as sales, marketing, HR comes in, put them in this group. So when Radius happens, when SSO and SCIM happen,
Okay.
we
So
grab
you
that.
could just leverage the groups they already have if they've got
Yeah.
that in their IDP.
Yeah, we're not creating anything new outside of their existing constructs of Radius and SCIM and IDP. Yeah. Attribute set is defining, I might be Shiv, but I have two devices, right? I have a corporate issued laptop and I have a phone. I'm doing SSO, so it's the same, right? How do you distinguish between the two? And that's where attribute comes into play. Attribute could be an EDR compliant laptop. It could be location, or time of day. It could be what SSID you're connecting to, whether it's wired or wireless. So now you can take that user group and tie it with an attribute set and create a more fine granular policy. And I'll show you an example in a minute, and it'll probably become more clear on what that means.
Really quick question on that. Without an agent on the endpoint, how are you correlating the different NIC identities on a device?
Yeah, so we are working with, Intune or CrowdStrike, right? So these...
You integrate with something already there.
Exactly.
Okay.
Right. Service profiles, I think that's very straightforward. SSH only, HTTPS only, ports and protocols, essentially. And policy sets is where you can create these actions. You can combine all of this stuff and say, I want to forward this out, to a SIMS platform, or I want to allow or deny, right? Or send it to Zscaler, right? So some SSC platform. But the key thing here is this is all based on zero trust principles, right? We are saying create the policy based on identity, whether it's fingerprint identity for IoT devices, or it's a user based on Radius or SCIM or SSO for that matter. So we make sure everyone is authenticated and authorized. We make sure it's continuously authenticated. So SCIM, if someone gets disabled, the policy would change dynamically. And then finally, we try and do deny all or least access privilege on how you want to set it up, right? So we try and follow those core principles.
So I've got a quick question.
Yes.
You've gone through a lot of how everything's secured. What about the devices that need access, like Apple TV or something, so that your users can share screen or things like that?
Absolutely. So you could go and first thing is onboarding that device, the Apple device. You can actually go and create a fingerprint rule and say anything that matches an Apple TV, for example, put it on the IoT segment. So when you plug that device in, if it gets fingerprinted as an Apple TV, it shows up in there. If it doesn't get fingerprinted, it'll be waiting for approval, and you'll have to manually move it into that segment. So now you're on the segment, you have an IP address, and now it starts advertising. So the key question is...
But how does the employee get to that device? Is there a rule that has to get created to allow that?
That is correct. Yes. The advertisement will be automatic, but when you click on it, if there's no rule defined, it'll basically get denied.
Okay.
Yeah. So by default, sorry, went too quick. By default, everything is denied in the NSP. Two devices on the same subnet also cannot communicate with each other, even though they're on the same switch, neighboring ports, right? Everything will be denied here, and there is what we call the trust engine, where you will have to create those rules to allow that traffic to go through. So what really happens is once you plug that device in and you have that microsegmentation enabled, employee can talk to a printer, then that traffic will be led through, through the policy engine, and that'll be allowed. And how this all comes together is with this one example. If I take John, and John is doing SSO, for example, when I do SSO, I do not know what kind of device you have. So whether it's John with his corporate laptop or it's John with his personal iPhone, I'll just get the group back saying employee, right? So if I create a rule based on employee, then his personal iPhone would also, land up being, getting access to the data center subnets or anywhere the employee can go. So here, what happens is the attribute set comes, in handy, where you can actually say, if it's John and it's an EDR compliant laptop, right, and he's connected to .1 SSID and he's, doing X, Y, and Z, that's the attribute set that you can form. You give him access to data center subnets. And if he does not have an EDR compliant device, then he just gets internet access only. So now it does not matter what IP address John is on, right? You could, if you want to put them on different subnets, you can do subnet-based policies. But what we are saying is do it based on identity. Do not worry about the IP. So you can literally have a /16 subnet. You can put everything on that one subnet, and you can have the policy, define what those devices can do. Now there are exceptions, right? There are your HVAC systems, right? There is Sonos, right, which needs broadcast to work. Create a separate segment, enable broadcast on them. and let them be alone. But anything where you can actually fingerprint and you can have these devices that need to talk, to the upstream router or firewall or your NSP subnets, you can create policies. So very quick, you have your policy here. You can click on that cell, and then you can just go and create that whole policy with a user group attached to an attribute set and apply it.